Did that work? Someone please confirm that that worked, I think.
Looks like it works.
All right, sounds good. All right. All right, so hey everyone. Welcome to the Setting Up Your Coding Environment workshop hosted by ACM Hack. So this workshop will be taught by myself, Henry Chan, as well as Garrett, if you want to introduce yourself.
Yeah, what's up? I'm Garrett.
Yeah. This workshop will just be going over setting up your coding environments and going over some basic fundamentals for what you should expect in your future classes, as well as just like any projects that you decide to do. So the link to the slides will be at acmurl.com/hack-setup. This is where you'll be able to access these slides later, as well as some of the links that we have embedded in the slides for different stuff like installation. The session will be recorded, as I mentioned before. So once this is uploaded to YouTube, you'll be able to see the workshop on the ACM channel. I'm looking at the chat right now. Nice. We can go ahead and get started with the workshop. So the checking code for this workshop is AOGit. So if you want to check into members.acmucsd.com and get your free membership points, then you can go ahead and do that with the code AOGIT. I think up in the chat someone posted a quick link that you can access to just check in right there and then. So if you scroll up, you should be able to find that. Otherwise, you can just check in at members.acmucsd.com. So now that we have the checking code out of the way, one thing you might want to do for installation before this workshop really gets into the nitty-gritty of it all is one thing you might want to download is Git. So if you're on Windows, then you'll want to install Git Bash, which is just an application that lets you use Git, which we'll be going over later in terms of like what that is and like what it does. If you are on Mac or Linux, it is already included within the Mac and Linux terminals, so you don't have to do anything for that. And then lastly, we have what are known as IDEs. We'll be going over that more later as well. These are optional. You don't really have to install them. And if you install one, you don't really need to install the others. For our purposes, we like to use VS Code. That's our preferred IDE, but a lot of other people use Atom and Sublime Text. So feel free to download one of these if you want to, but otherwise, don't worry about it. So other than that, we can get started. So for today's agenda, what we'll be going over first are command line interfaces. So we'll be going over what is a CLI as well as how to use it. Later on, we'll be going into what IDEs are. So as you saw on the last slide, some examples of those were VS Code, Atom, and Sublime Text. So we'll be going over like what those are and what you can do with them. And then lastly, we'll be going over what Git and Version Control are, which at a high level is basically just tracking your changes in your code. So with that being said, we can get on with the workshop. So the first thing we'll be going over are what CLIs are. So CLIs stand for command line interfaces. And so these command line interfaces are are one way that you can use to basically interact with your computer as well as the computer system, as well as just do a bunch of different really cool stuff with it. Going more in depth into that, a CLI is a text-based user interface for typing in commands to run different tasks on a computer. So with these different commands, you can do a lot of different interactions, do a lot of different things on your computer. You can do stuff like easily moving around and editing files. You can execute different programs, and you can display a lot of insightful information about your computer in terms of just like computer logs or just like what processes are running. And you can all do this with like a couple of keywords, and a lot of these keywords are pretty short too, so it's not a lot of keystrokes either. So in terms of what you should or why you should know how to use a CLI, is that using a CLI usually offers more precise control over a computer system. So there's a lot of things that you can do with the CLI that you can't really do with just by like clicking on a screen or just like moving around to like your computer system like through like the file explorer, or at least it's much more difficult. And so a CLI definitely offers you more ease of access in terms of doing that, as well as just like more granular control over that. Another thing that you can do with a CLI is that if you learn different CLI commands and you sort of like memorize them, it can actually be much faster and more efficient than just having to click and navigate through multiple windows and screens. So something like finding like a certain like file or folder on your computer, you can actually easily do that with just by typing in a simple command just to like search for the name of the file, instead of just having to like click through like multiple levels of folders and stuff. And then the last thing that you should know about CLIs in terms of like why you should know how to use one is that CLIs are usually lightweight, and they often use less resources than say like a graphical user interface like File Explorer or just like something else, because really all it is basically text-based. So all you have to do is like just type in a couple of words. Graphical user interfaces, they tend to actually require resources for like displaying information to the user on the screen. And sometimes this can actually be slower and load up less faster than like a CLI. But yeah, any questions so far on that? Okay. All right, sounds good. So now we're going to move into different examples of CLIs. So here we have a couple of screenshots of what CLIs might look like. So one CLI that you might encounter is the Mac terminal. This you should be able to find on your Mac just by like searching for it in, I believe, applications. And you can easily just pull this up and start typing different commands. Another one that you'll see is Git Bash on Windows, which I mentioned earlier is something that you should install if you have Windows. This is sort of like the terminal CLI that Windows users use. There are a couple of others, but this is usually the one that most people use. And then lastly, if you're on Linux, you have the Linux command line, which as you can see, looks pretty similar to the one that you have on Mac. So these are just a couple of different like CLIs you might encounter. There are definitely more out there that look different from this, but these are sort of just like the main CLIs that you'll encounter. So now that we've talked about what a CLI is and how you can use it, now we're actually going to go into like sort of the different commands that you can use to interact with your CLI in your computer, as well as what a directory structure is. So some basic commands to know when using like a CLI are some basic like navigation commands. So here we have 3 commands listed that are mainly used for just navigation. So the first command that you'll see is ls. And this is usually just short for list. And this is basically what you would use to list all the files within your current working directory. And so what your current working directory is basically the folder that you're currently in. So whether or not that's like your desktop level or say just like a random folder that you have on your computer, if you're in that current directory, then that is your current working directory. And if you type in ls, it will just basically display all the contents of that folder. Another command that you can know sorry about my voice, is the pwd command. And so pwd basically stands for print working directory. And this will basically just print out the path of your current working directory. So if I'm currently on the desktop folder, then it will just print out like C drive, user, Henry, desktop, and as well as like all the slashes in between. And then lastly, we have the cd command, which basically stands for change directory. And so this is what you'll mainly be using in order to sort of like navigate through your computer, through all the different directories and files. And yeah, so it basically allows you to change directories to a specific directory if you're given a path or like an argument for a file, or it will just default to the home directory if you don't provide any argument after the cd command. And so what your default home directory is, this is usually often denoted by the tilde sign, which you can see right there, is it's basically your default directory. It's sort of your home directory that you'll always go to if you just type in the cd command just on its own. And this is usually something like maybe desktop or like the current user. And it's sort of just like this very high level folder within your like computer system. And then if you want to go up one directory, then you can just run the command cd ... So ... is basically what represents the directory that's right above the one that you're currently at. So if I say, if I'm currently in like a folder on my desktop called like hack school. So if I'm currently in a hack school folder, then the next directory that I can reference using ... would just be desktop, since that's like the folder that's right above hack school. And then lastly, if you want to just access the current directory, which in most cases you can just do with all these commands on their own, is just using ls dot, or sorry, one dot is how you would reference the current directory. So for example, if you were to type in ls dot, that would basically just list all of the files in your current directory, which can also be just done if you just type in ls, since most commands they usually reference the current directory if not given any specific argument for that. So right now I can just go ahead and share that real quick just so you can see an example of like these commands running. So I'm going to pull up Git Bash since I'm currently on Windows. So you should be able to see that. So right now I'm currently in my home directory, which you can just see by this tilde sign right here. So if I were to type in ls right now, then as you can see, if I type in ls, you can see all the different sorts of directories that I have currently at my home directory. So you can see stuff like desktop, documents, downloads, stuff like that. And so if I were to sort of type in pwd just to print out the current working directory, just to see like what my home directory is located at, then I can type that and you'll see that I'm currently located at C drive, then users, then just the current user. And then lastly, I can go over what the cd command does. So I guess right now, if I were to go into, say, the desktop folder, then all I would have to do is just type in cd desktop. And then right now you can see that my current directory has switched from home directory / desktop. And if I were to type in ls, then you can just see everything that's on my desktop. But yeah, and if I were just to go back up one level, I can just type in cd .. And now I'm back in my home directory. And then same thing if I just type in cd. Yes, I do have League of Legends on my computer. But yeah, so that's sort of like the commands that you can use. Garrett's putting some other useful commands in the chat right now, but I'll go ahead and switch it back to the slides. Does anyone have any questions on like commands, directory structure, or I guess just CLIs in general? Yes, uninstalling League is definitely a good tip for succeeding in school, but I am a degenerate and I don't want to. But yeah, cool. If no one has any questions about CLIs, then we can go ahead and move on to the next slide, which is going to be talking about IDEs. So IDE, it basically stands for Integrated Development Environments. And so what these are, so an IDE is basically an application that combines different development tools into a single graphical user interface or GUI. And so yeah, so this is something that you'll often install, like maybe VS Code, Atom, or Sublime Text, one of the three that I mentioned earlier. And these are basically applications that you can use to write code, as well as just like help you develop as a programmer. So IDEs, they usually consist of at least the following tools. So they usually consist of a text editor, which will where you'll be writing most of your code. And often it will come with like syntax highlighting and autocomplete, which will help make writing code easier. So if for any reason, like say you forget like what a function is in like Python or something, or like Java or like JavaScript, usually like your text editor will usually come with like an autocomplete function that will help you like sort of like list out all of the options that you have for that function. Syntax highlighting is also a helpful feature because it like just sort of like highlights keywords that'll help you like see basically read your code better. Another tool that an IDE usually comes with is a compiler. So this will usually compile and build your code into an executable program that you can then run and basically just see your program in action and just like run the output to see what it looks like. And then lastly, an IDE usually consists of a debugger. So this will help basically run any executable program you have that you might have compiled from your code, and then let you test it as well as display like potential bugs and errors. So with debuggers, you'll usually see like the outputs of like different variables or just a lot of different things to just help you debug your code and make sure that it works properly. So these are sort of just like the basic functions that an IDE has. Different IDEs will have like more or like less functions. And we'll be going into later how you can actually add more functions depending on the IDE that you're using. So right now we have an example of an IDE. So this is VS Code. This is sort of the interface that you'll see when you go into VS Code. This is just sort of a screenshot, but I can go ahead and share VS Code right now just so you can get a more sort of interactive walkthrough of it. So right now, VS Code should be up on my screen. And so right here, right smack dab in the middle, you should be able to see just like a bunch of different code. This is sort of like your text editor area where you'll be just writing code. You can see that there are a lot of colors. This is basically just like the syntax highlighting feature that I mentioned before that you can like easily sort of like read your code. And then you also have like a lot of like autocomplete functionality. So say if you hover over something, you can see like what different functions take in, and just like you can just like type stuff in and it'll like autofill with like functions and stuff. And yeah, on the side, you'll see a sort of like folder tree of like all the different files that you have in like your current directory. This is usually really helpful if you just need to like switch between files. Also at the top, you can see like a bunch of like different tabs just so that you can like switch between files a lot easier. So I can go ahead and just like switch between different code files just so you can easily see that. And then, yeah, at the top, you can see like there's just a lot of different like menus and functions that you can use. So here you can see that there's a run option. This is what I was talking about in terms of like running like a debugger or something. You can see up here where it says like start debugging. And then just a lot of other stuff that you can do. Over here, there's a lot more different functionalities that you can like look up. There's even things like where you can like search in your code for like different keywords, which is honestly really helpful if you have like a really long file. And yeah, one thing to note about VS Code in particular, which some other IDEs don't necessarily have, is that VS Code comes with a built-in terminal. So like it's a command line interface that you can use right here, similar to like what I was showing you before with Git Bash. So here you can just sort of like type in commands, like you can type in ls, and you can like see like your different files. And it basically is just everything that a coder would need all combined into like sort of one application. So yeah, it's basically like your one-stop shop for any sort of like development. Yeah, so that is VS Code. I'm gonna go back to the slides. Yeah, so then the next thing that I want to talk about when it comes to sort of like IDEs in general is that a lot of IDEs will be able to allow you to have a lot of different customization options and different settings. And many IDEs usually allow the user to install additional features through things like extensions, plugins, and add-ons. And so these different like plugins, extensions, and add-ons, they sort of allow the users to do a lot more different things in terms of just like a lot of different features. It's sort of like, it's basically sort of like installing apps on your phone, but with VS Code, it's sort of installing apps that will help you basically make programming easier. So for example, VS Code actually has the marketplace. So I can go to that link right now. And so here in the VS Code sort of marketplace, you can actually see like all the different extensions that are available to you. So a lot of them say like GitHub Classroom or like Python or like C++, just a lot of different things. These are basically a lot of things that can help you basically make your VS Code experience more customizable, as well as more tailored to your needs in terms of like what you're actually coding. So yeah, this is like sort of a website that you can check out. The VS Code Marketplace is also something that's available on the VS Code app itself. But yeah, so in terms of that, like in terms of like the sort of like applications you can install for the extensions, a lot of the stuff usually comes in the form of better programming language support and syntax highlighting. So natively, like just automatically, VS Code does come with some syntax highlighting and autocomplete, but it doesn't contain everything. So there are like some extensions for like specific programming languages that will help you sort of like add more features to that. Another thing that you can do is add extensions that will help better integrate with like different external applications like GitHub and Docker, which can be really useful when you're sort of like integrating with like different sorts of applications. And then one of my favorite is the ability to actually start live collaboration sessions with others so that you can actually work on code together at the same time simultaneously. And then just besides that, there's plenty of other sort of like extensions that users can download. It's just up to you and like your needs in terms of like what you actually need to help you code better. But yeah, so that is IDE extensions. And I believe after that, we're going into Git and version control. But before we do that, does anyone have any questions in terms of just like IDEs in general? Okay. All right. If no one has any questions, then Garrett, you can take it away. I'll go ahead and give you a screen share.
All right, sure. Just give me a sec here. Apologies for the background noise. Let's see. All right, so I hope everyone can see my screen. I'll just keep chat open in a different window. Okay, so I'm going to be talking about Git and version control, aka how to get good. Right. So why do you need version control? For one, this is important for keeping track of changes in your code. So no more of this nonsense where you're like renaming files and this is the final file. No, this is the real one. Like none of that, right? You just keep track of it all in like one cohesive thing. Also for maintaining a history of your project, right? So if you screw something up, having a reference point to go back on to know exactly what change messed up your project is important. And also for collaborating with other people on the same project. So you don't have to, go back and forth emailing files or anything. Or using Google Drive, which is really bad for code. Right. So what is Git and what is GitHub? People often get confused as to like what the difference is. So GitHub is a place for Git repositories, and Git is the actual version control software that almost everyone uses. So there's other types of version control out there like Mercurial or Subversion. They aren't as popular. Yeah, barely anyone uses them. So Git is really the main one that you should know. And if you need like an analogy for this, think of GitHub like a library and Git repositories are books. And I guess Git would be like a printer or a pen, for example, to write these books. All right. So I guess I'll be going over some basic commands with Git. So Git Init initializes Git, so it makes the current folder into a Git repo and lets you start tracking stuff. Git add, and then you type in the files here without the little angle brackets there. It adds the files and stages them to be committed, and then Git commit actually commits the stage files and saves them to the history. So this might be a bit confusing. Basically, staging it is like getting it ready to be committed. But it doesn't actually make the commit until you actually type git commit, right? And so this lets you like get files in and out of staging and not have to like worry about affecting the tree of commits. So Git push will upload your commits to GitHub, but you'll first need to link your GitHub repository and your local repository. So I'll show you how to do that later. And then the last two commands are more informational. So Git status shows the current status of the repository. So like what files you staged, what files you're going to commit, etc. And then Git log shows the history of commits, just so you know what commits you've made. All right. And so real quick, I'm just going to show off how to set up a project, a new project in Git. So basically it's just navigating to your project folder, typing Git Init, adding the files, and then committing it and then linking it with GitHub. So I have my terminal open here. So I'm just going to create a new folder using the make dir command, I guess. Example repo. And then I'm going to navigate into it with the cd command that we learned before. So now this is an empty folder here. So right now I'm just going to create an empty file with some text in it, I guess. So Vim is just a text editor that I like to use. Yeah, so let's say I just add some random text here and then I save. So now I'm going to type Git Init, and that will initialize the repository in the current folder. So you see example repo on master, that's the name of the branch. So then I'm going to type Git Status to check, okay, so this tells you pretty much everything you need to know, right? We're on branch master. There's no commits yet because we just created this repo, and we have untracked files, readme.md. Right, so how do we add this file? Well, there's a few different ways to do it. We can either do git add -a, and that will add everything in the repository. So I guess I could do that. But like, what if you have files you don't want to commit? Well, you can just type git add and then the file name, for example, right? This is useful if you have like an NPM project, if you've done Node.js before and you don't want to commit like a huge folder called node modules. That might be kind of annoying to deal with. So you probably don't want to add that. All right, so now that we've added the repository, not the repository, the file, sorry. I'm gonna run git status again. This is a good like sanity check to do after each command, just like make sure what you did actually worked. So as you can see, okay, changes to be committed, new file readme.md. So that makes sense, right? That's what we want to do. And now we're actually going to make the commit with git commit. And then you can just type git commit and it'll give you an editor that you type your commit message into. But I like to just do it on the command line with the -m flag. And then inside of these quotes, you can type your message. In this case, it's pretty common practice to do initial commit for your first commit. So once we hit that, we now have our initial commit right here. So I'm just going to say git status again. Now you notice because we made the commit, we have nothing to commit, working tree clean. And if we want to see git log, we can see, okay, this is our commit that we've made. So hopefully that makes sense. That was like a lot of commands that I just did. If you're not familiar with this, it might be kind of overwhelming. Yeah, feel free to ask me any questions or stop me. Anyway, so yeah, and then I guess now I can try connecting this with GitHub and sort of demonstrating that as well. So here, let's see, I'm just going to go onto GitHub. I'm just going to make a new repo just for this. So I'm just going to call this example repo. If you don't have a GitHub account, you should probably create one, by the way. Just go to github.com, set up a new account. It's useful for just tracking, you know, your code and all that stuff. Yeah, and I guess I'll just make this public, and we don't have to worry about any of this. All right, so now I'm going to link the repository. So this is the link to the repository. I'm just going to copy that. And then I'm going to go back to our terminal and type git remote add origin, and then the link. So this adds what's called like a remote branch. And this is essentially what sort of keeps this in line with GitHub. And we call it origin just by convention. You can technically name this whatever you want, but most people just use origin. Anyway, so now we can type git status again, just to like check, and then we can do git push -u origin master. And the -u essentially says to, okay, we're going to create a new branch in origin because this is a new repository with no branches on it. So that's what the -u does. All right, so looks like the push was successful. If we refresh our repo here, notice, right, this file with random characters in it is now on GitHub. And if we want to make a change, I could do that real quick. So cd, I want to make a change, let's say, I don't know, test repo. Save it, right? Then we're going to do git status just to check, okay, we have a file we need to change. We need to stage for commit. So I'm just going to do git add, and then the file name, and then git commit -m, and then a message describing your commit. So I'm just going to say added title to right, and then we're going to commit that, do another git status just to check. As you can see, your branch is ahead of origin master by 1 commit. And then we can use git push to publish our local commits. So because we already set up the remote branch, we can just type git push and hit enter, and it'll push these changes right onto GitHub. And so if we refresh, you can see now the change we just made is right here. And we can see the last commit right here, added title to README. So hopefully that makes sense on how to connect Git and GitHub and how to set up a basic repo. Are there any questions? Show how to access the last version. Yes. So for that, you can use the git checkout command. So if we do git log, for example, we can see each commit has a specific ID or a hash. And that's what this string of stuff is. So you can go back to any commit just by essentially copying usually the first 6 characters and just doing git checkout. Hopefully I remember this. Yeah, so now, for example, this will now switch us back to the previous version. And if we open up the README file, you can see now this is the last version, right? This is the random characters from before. I don't know what's going on. I broke Vim. Hold on. Crap. Okay, well, let's not worry about that. All right. Yeah. Are there any questions? Hopefully that answered your question. I'm going to open up a new terminal. All right, nice. Okay, so anyway, so this is the sort of diagram you should memorize. This describes essentially the whole workflow of Git and how to do things. So you have your local repo and then the remote repo. So the local one would be the one on your computer. And then remote repo would be the one on GitHub. So your working tree is essentially your actual like files and folders, right? And then the index staging area, so that's where when you do git add, that's where the files end up. And then actually running the git commit is what commits these changes to your branch. And then git push is what pushes it to the remote branch. You also have this sort of intermediate stage, the remote tracking ref. And this essentially keeps track of what's going on in the remote branch, but in your computer. So you can, for example, do a git fetch, which is another command I didn't mention here. But if you were to use that command, that would essentially pull changes from GitHub, but not necessarily change your files to match that. That'll just store them into the remote tracking ref, that part. So yeah, this you'll learn this in CSC 15L. I remember being quizzed on this and having to like fill in the blanks or something. So if you're going to take that class, just memorize this now, and you don't have to worry about it later. All right. So a major advantage of Git is that you can keep track of different versions of your code. And why would you need to do this? Well, this is useful if you have multiple people working on the same project. Sorry about that. Multiple people on the same project. So let's say, for example, you have like 4 people and they're all like changing different files and stuff. Having different branches is going to be super helpful, so you don't have to deal with conflicts all the time and like overwriting people's changes if you were to be using like Google Drive or something. And another advantage is that you can add and test new stuff without breaking existing stuff, right? Let's say you have a really pristine main branch that like works and everything, and like you're deploying stuff from there. If you want to test something new, you don't necessarily want to break that main branch, right? That works and potentially affect users that are using your product or whatever. So essentially, having this multiple branch like lets you create a separate branch, add your new things, test it, make sure it works, fix all the bugs, and then once you're ready, you can merge it back into the main branch. And so the commands for this are git branch and then the branch name without the angle brackets to make a new branch, and then git checkout to switch to the new branch. So I can just demonstrate that really quick on the terminal. Let me just make this a little bigger. Okay. So I'm going to go back into the example repo. I'm just going to go back to master just to do this. By the way, master is kind of an antiquated term for the main branch. Most people use main nowadays. Yeah, they're kind of transitioning. Anyway, so if we want to create a new branch, we can type git branch, and then, I don't know, we'll just call this new branch or something. Notice how we're still on master, so we're going to do git checkout new branch. Yeah, okay. So as you can see from my terminal tells me what branch I'm on. But if you want to check for sure, you can do git status and it'll tell you, okay, we're on branch, new branch. And I guess a shorthand for this, if you don't want to type git branch and then git checkout, you can do git checkout -b. And then I'm just going to do this with another new branch. And doing this will create the new branch and automatically switch to it. So this is just a nice little shorthand if you don't want to type 2 separate commands. And basically any change that we make on this branch will not affect the main branch or any of the other branches. So that's really useful there. Anyway, hopefully that's okay for most people. I'm just going to move on if there aren't any questions. So now I'm going to go over pull requests and collaboration. So pull requests are a way to merge different branches on GitHub. So essentially, if you have a branch, let's say, and you added some stuff, you changed some things, you want to merge it back into the main branch, typically you would create a pull request for that. So for example, in open source, right, if you made a change and you want to contribute to some project, you would make a pull request, and then someone would review it and eventually merge it. So to create a pull request, you simply go to the pull request tab of the repo and then click new pull request. And then you can just select the branches you want to merge. And I described here, most repositories will have a main branch, usually called master or main nowadays. And you can use this and they'll create new branches and add new features and then merge them in through pull requests. So that's typically the workflow you'll see in industry and different projects. So on the GitHub site, you can see this section here, pull requests. So I can, for example, make a change on the example repo that I created. So let's say I'm going to check out new branch. and git commit, or sorry, getting my commands confused. Okay, then I don't know, some text here. All right, I quit Vim successfully that time. Nice. I'll run git status again just to check. Okay. So another shorthand that I can show you guys is git commit. If you -am, that'll simply commit all the files that you've changed that are tracked. So if you have a new file, this won't work. But since README is already tracked, since you've already git edited once before, then you can type git commit -am and then just do like, I don't know, changed text, or I guess added text. And it'll just automatically add those files and commit it all in one command. So another useful shorthand, git commit -am. Right, so now we have a new commit on our new branch. So what do we do now? Well, same process as before. We're going to do git push -u this time, origin new branch, similar to how we initialized the master branch at first. Right, so now it says, branch, new branch set up to track remote branch. So if we go on to GitHub, where is it? Okay. We can see, okay, we pushed a new branch here and we can check this indeed, the text we added here is here, but it's not in the main branch master. So we can pull request it by doing this, compare and pull request, or you could just hit new pull request. And you can essentially select what branches we want to merge. So we want to merge our new branch into the main branch. So this is the base branch, and then we're comparing it to this. And then we just click create pull request. And then you can essentially describe what you changed here. Typically, a lot of open source repos have like a certain format that you should follow. I guess for personal projects, you can just kind of do whatever. Yeah, I'll just hit create pull request. And then it'll look something like this. Now here, if you have multiple people working on a project, is a chance for code reviews. So you can look at the files that you changed, and then I guess I'll review my own changes. You can make comments, for example, right? Right, so you could do something like this. And then, let's say your code is good, you can approve it. LGTM looks good to me. And then, oh wait, I have to, okay. Yeah, so like you can do this, like approve your changes or have someone else review it. And then when you're done, you can hit merge pull request. There's different ways to merge. Yeah, I guess I could explain these because we do have some time. So create a merge commit basically takes your current commits in your branch. So if you have like a bunch of commits, it'll simply push them onto the main branch and then have another commit on top to say that you merged everything in. Squash and merge, I think, is probably the option I like the most. This is essentially taking every commit. So if you have like 50 commits or something and squashing them all into one commit and then putting that onto the main branch. And then rebase and merge would just be sort of similar in that it'll just take all the commits and just rebase them onto the main branch. So it doesn't squash them. So in this case, I'm going to do squash and merge. I think most people prefer that style, just so you have a clean tree of commits. You don't have a bunch of branches and stuff going everywhere. So once I do that, you can change the commit message and all that, confirm. And now it says merged, right? So it says one is closed. And then here, now we have the change that we just merged. So hopefully that makes sense with pull requests. Yeah. feel free to ask any questions in chat if you're confused. Yeah, so I do have an example repo that you all can try making a pull request to. Does new branch disappear after completing the pull request? So typically, yeah. Let's see. You can specify. So GitHub typically deletes the branch after you merged it. If you don't want it to delete it, then you don't have to, right? But yeah, it is best practice to create a new branch, add some stuff to it, and then get it merged, and then delete the branch afterward. So yeah, the new branch is deleted. All right, so I guess I'll be running through the same example with this repository here. So I just created an example repository that you all can add your name to and make a pull request. So I'll just go through the whole process. And if you want to follow along, you can. You don't have to. So I'm just going to start by cloning the repository. So, oh yeah, so you should probably fork it first. So forking is just a way to essentially create a copy of the repository on your own account. So sometimes you won't have permission on some of these big public repos to create branches and stuff. So forking it would essentially make a copy of this on your own account. So I guess I'll do that. So now I've created a fork. Here it's on my personal account instead of ACM UCSD. So now I'm going to clone this. So I'll just go back to home, and then I will just git clone, that's the command. And so now if we go to git workshop example, we can see, okay, we have the README here. And if we look at it, you can see, okay, this is the same as the text before. So what I'm going to do now is just add my name here. Right, and then git commit -am added my name. I'll do a git status here to check. So we're ahead by one commit, so I'm just going to do git push to push the commit. And now we've pushed onto the main branch. But this is the main branch of my own fork and not the main repo. So for that, I'll have to make a pull request to merge it. So here, I'm just going to go to pull request, new pull request, and we're comparing. Oh, compare across forks. Okay, so you need to hit this to look at different forks. Right, so here it is. So then I'll just create the pull request. You can add a short description. This PR adds my name to the README. Right, and luckily we have no conflicts. So I'm just going to merge this in. And there we go. So now my name should be here. And so that's just a quick demonstration of how to do pull requests. Right, so sometimes you'll run into merge conflicts when you're making a PR. So for people making PRs right now, you might run into a merge conflict because I changed this file, right? So the way you do that is you should probably pull the repository first from the main branch, and then go into the file and just manually fix it. So yeah, each file will tell you where the conflict is and different versions of the code. And then you have to choose which part of the code you should keep. And then after that, you would just commit it. So it's pretty simple. Sometimes merge conflicts get really bad and you have like, hundreds of conflicts. But some IDEs have a way of letting you handle that pretty easily with an interface. VS Code, for example, has a pretty good interface where you could just essentially choose like what to merge and what to keep. So it's pretty nice. Right, and then lastly, I'll just be going over some best practices when it comes to Git and what you should do. So first of all, commits are atomic. So one change, one commit. This is the sort of ideal here, the platonic ideal you should be striving for, right? If you make like 100, 1,000 line commit, that's not really good because like if something breaks in that commit, right, you don't know exactly what broke it. You don't know which of the 1,000 lines could be causing that issue. So try to keep commits as small as possible. So a good example would be just changing a button color, for example. Bad example would be overhauling an entire interface. And then pushing to master or main. This is okay for smaller personal projects. So if you're just doing like, you're making a Discord bot for your friends or something, or you're updating your personal website, stuff like this where it's like only you and it's like a really small project, then it's fine to push to main, but take advantage of branching when you're working in a much larger project or with other people, right? Because pushing straight to main is just like not really ideal because you can get all sorts of issues with that. So next thing here is always pull before you push. So in this example here, I made this change here. So if you didn't pull before you pushed, then what'll happen? You'll end up creating some weird conflicts, right? So if you pulled before you push, then it'll essentially try to resolve those conflicts locally and then let you make a pull request without having to deal with these issues. Because you never know, especially on a team project, before you push, right, new changes could have been made that might affect the files you're working with. So lastly, commit messages should always be descriptive. So I'm kind of bad with this, right? Where you make a commit that's just like added things or like change stuff. Try to avoid that, right? Try to describe, okay, like what you changed, what you added, so that it's just more helpful for other people. If you're collaborating on a project, for other people to know exactly what this commit does. So in case something breaks, right, then you could easily, go back or whatever, or just know what you did and why it broke. So yeah, I think that's pretty much it. Yeah, thank you for showing up. This was, I guess we ended like an hour early, but yeah, hopefully you learned a lot about coding environments and Git and IDEs and terminals. If you have any questions, feel free to ask them in chat. And if you have any requests for further workshop topics that we should cover at ACM Hack, then you can go to this link here and make a request.
Thanks everyone for coming.
A lot more useful than 15L. Yeah, that's kind of true. 15L was oh, we can stop the recording.
Oh, yeah. Stop recording.